Hello, good morning. This is Piotr speaking. That's Quasar Training, Part 3, 2020 update on Linux. For a small recap, in the last part, in Part 2, we looked at how to work with Quasar design, and we added a simple motor class representing some sort of intelligent motor. And in this part, we'll look at variables and especially at cache variables, and we'll add a few cache variables to your motor example. So variables are the following. A Quasar variable generally translates to an OPC-UA variable, which means one declared Quasar variable is always an OPC-UA variable. Variables in Quasar are declared per Quasar class, and this is a restriction compared to OPC-UA, in which a variable can be basically anywhere. In Quasar, it's part of a Quasar class. In Quasar, we have two types of variables. We have cache variable, which is for representing state of a real thing, of a real part of a control system, and it applies whenever state can be cached in memory. And then we have source variables when state cannot be cached in memory, and each access from the client, so whether it's read or write, must contact the data source or data sink directly. And the common thing between both of them is they are of predefined data type. Most of built-in primitive OPC-UA types are supported in Quasar, so that involves like floating points, integers, boolean strings, and stuff like that. There is also a generic type which corresponds to OPC-UA variant, and you can use scalars or one-dimensional arrays. This is what we support in Quasar. So let's now focus on cache variables. Cache variables are always readable by OPC-UA clients, and that is because there is always an in-memory representation of the state, so you can always read it. Whenever a client wants to read or sample a cache variable, this always returns the in-memory state. That means this always gives you the last information that was pushed to the memory or pushed to the cache most recently. If you wish, a given cache variable can be writable by OPC-UA clients, and that is controlled by the design. If you make it writable, then you can have an additional thing, which is your custom code can be called whenever any client writes to this variable. This is called delegation. Will not be covered in this part of the training, but will be covered a bit later. Now, all cache variables can be given initial value, either by Quasar design or by configuration. The initial value is what you see in the server's address space after it started, but before there was any updates by your custom code or by clients. So this is the initial value. Cache variables are the best in terms of performance, and major takeaway here is they should be preferred for all cases when state can be represented. Now, speaking of state, as it might be a bit vague, a state is a property of your real control system thing, any property that is valid for a period of time. That means you can speak of voltage or flow or speed or position or whatever like that. Those are usually measurable things or things which are configured, which stay as a property of this part. So the voltage is a perfect example. So let's now look back at our motor example. And let's add a few cache variables to give some, I hope, meaningful examples on what cache variables are and how to use them. So first of all, we'd like to add rotational speed because I'd like that my server exposes the information on the current motor's rotational speed in revolutions per minute or another meaningful unit to my OPC-UA clients. So I'd like that my rotational speed will be kept up to date by the server and clients should not write to it. Okay, so this will be one directional transfer of information. The server will obtain this information from this motor controller and will pass this information to any interested client. As it's a speed, any floating number will probably do. And my wish is it will be initialized to something like unknown. That means that when I start my server, before I obtain the information from the factual motor controller, I do not know what it actually is. The second variable I'd like to add will be different from the first one in the sense that this one will be written by client. So this one, so the rotational speed, my intention is it passes information from the server to clients. And the set point, my intention is that client passes information from clients to the server, to the motor controller, because the intention is that the clients can control the intended rotational speed by setting the set point. So it needs to be writable because it will be controlled by clients. Again, any floating number should do, at least for the moment. And I'd like that whenever I start my server, the initial value would be 0. Those are my wishes. Now let's put that information into our server. So I'll start from Eclipse again. Okay, so this is my Eclipse project, the one we finished with in part 2. And you remember I had a class called Moto, and I will now start adding those cache variables. So the first one, I right click on class. I say add child cache variable, and I said the name should be rotational speed. Some nice floating point, so double is just fine. I said that I do not want clients to be able to write to this, so forbidden is just fine. It means the client will not be able to write to this. And I said that I want to get this initialized by, let's get back to the slides, should be initialized to something like unknown, because we don't have this information. We possibly don't have this information when the server starts. So I'm saying initialize with value and status. And here's the trick. I will give the status to be waiting for initial data, but I will not give the value. So it will have the status code like that and no actual value. Okay? And the next one, the next cache variable. And I said it should be rotational speed set point. I said it should be writable by client, so I'm saying regular. Regular is just, plain writable without delegations, so delegations will cover in the next part of this tutorial. So now let's cope with the initial value. So we said we'd like to have it initialized to 0 when the server starts. And so here's the trick. I say its value is end status, but on contrary to the previous one, I will add both attributes. So the status to be good, which is just fine, and the value to be 0 as I wished in my intentions. So let's have a final look. All attributes look good as the name, now policy, add the space right, initial status, initial value. So we're good to go. Let's save the design. And we get back to our project as we left it in part 2 with the changes we just made in the design. And let's see how, before building the server, let's see how it looks on the visualization. So we run generate diagram as in the part 2. And now we see that our motor class was extended with 2 additional things. Now, a little trick that I'd like to teach you. So Quasar diagrams have different levels of detail, and the default level of detail is 0, which is pretty much compact, but you don't see what the things are. So let's increase the level of detail. Let's say it's 1, and now we see that the 2 things that we added to our motor class are cache variables. So CV stands for cache variables. There will be few additional types of things that we can add per class, per Quasar class, which we learn about in next parts of this training. So far so good. It's time to build our server. And let's run our server. And let's see what it's exposing via using UA Expert. And voila, as in the previous part, we see 2 objects, M1, M2. They come from the config file definitions. But now inside we see those 2 variables that we added. And I can subscribe to them by drag and drop. And the primary difference I see comes from the initialization we chose. So for the rotational speed, no value, and a status code saying waiting for initial data, and a nicely initialized value of 0 from the last from the initial values from the design. Now I'd like to welcome you or show you the attributes window of UA Expert. And there we can see a lot of information on any variable, any object. And here particularly we see the access level is read only for rotational speed, and read and write for rotational speed set point, which means clients can actually write to the set point. All right, so that was part 3 of the training. Sorry for technical issues, and thank you for your attention.